10 Eiffel Towers stacked on top of each other, a depth twice that of the Grand Canyon, a rock temperature of 66 degrees, pressure that bends steel beams like putty, and at the very bottom, 4,000 people descending every day to pan for gold. Welcome to Mponeng, the deepest mine on planet Earth, a place where everything we know about the familiar world ends and something entirely different begins. Today, we'll journey from the surface to the very bottom, floor by floor, kilometer by kilometer. We'll discover what it's like to work where no ray of sunlight penetrates, where rocks are older than life itself, where walls shift and groan under the pressure, and creatures that haven't seen the light of day for millions of years live in the cracks of the rocks. Get ready, because what lies inside the deepest mine in the world turns out to be far stranger and more wondrous than anyone could have imagined. Let's be clear, when we say the deepest mine, we mean the deepest working in which people work. There are boreholes drilled deeper. The famous Kola super deep borehole in Russia reached over 12 kilometers, but these are simply holes in the ground, 23 centimeters in diameter, too small even for a child. Mponeng is something entirely different. It's an underground city, hundreds of kilometers of tunnels through which trains travel, 4,000 people work, pump water, supply electricity, and cool air. It's a place where humans are physically present at depth, where no sound from the surface penetrates, where rocks are older than life itself, and the pressure is such that steel beams deform. And it is there, at the very limits of human capabilities, that scientists have discovered something that could change our understanding of life in the universe. Mponeng is located in the Gauteng province of South Africa, approximately 70 kilometers southwest of Johannesburg. The name translates from the Sotho language as, "Look at me," and it must be said, the mine lives up to its name. It is part of the Witwatersrand, a geological formation that contains the largest gold reserves on Earth. Nearly half of all the gold ever mined by humanity came from here. The 1886 gold rush led to the founding of Johannesburg, a city literally built on gold, and the Witwatersrand mines have fueled South Africa's economy for a century and a half. But where did so much gold come from in one place? Geologists believe the Witwatersrand is an ancient riverbed that existed approximately 3 billion years ago. Rivers washed gold particles from the surrounding rocks and deposited them as placers, which were eventually buried under kilometers of sediment, turning into gold-bearing strata. 3 billion years is 2/3 the age of the Earth. The gold mined from Mponeng today was carried by rivers that flowed across the planet long before the first multicellular organisms appeared. Miners are essentially mining ancient riverbeds, buried 4 kilometers deep by tectonic processes. Mponeng began operations in 1986 and has been steadily deepening since then. The current depth is approximately 3.8 kilometers, but in 2024, Harmony Gold approved an expansion project that will bring the mine to 4.2 kilometers and extend its life by another 20 years. But enough numbers. Let's go down. Your workday begins with a queue for the elevator. Not a regular office elevator, but a freight cage designed for 120 people. You stand shoulder to shoulder with other miners, wearing a hard hat, a headlamp, overalls, and, obligatory, an emergency breathing apparatus. The doors close, and the cage begins to fall. No, not descend, fall. The speed is about 16 meters per second, almost 60 kilometers per hour. The pressure in your ears builds, like on an airplane landing. The first elevator carries you to a depth of 2.5 kilometers. The descent takes about 4 minutes. You emerge at an intermediate level, an underground station lit by dim lamps. Here you transfer to a second elevator, which takes you even deeper, and from there, it's on foot, or by underground transport through tunnels that stretch for hundreds of kilometers. The total length of the Mponeng workings is almost 400 kilometers. It's like the distance from Moscow to Nizhny Novgorod, only underground. The journey from the surface to the working face takes over an hour, more than an hour each way, every day. And to the farthest points, it can take up to 3 hours. This means that out of an 8-hour shift, 2 to 6 hours are spent simply on travel. But travel time is not wasted. It's on the way down that your body begins to sense that something is wrong. At a depth of 1 kilometer, you notice a warmer atmosphere, as if someone turned on the heating. At 2 kilometers, the warmth turns to heat. At 3, it becomes stuffy, making you want to unzip your overalls. At 3.5, you're breathing air that's hotter than a summer day in the Sahara. The fact is, the Earth warms with depth, approximately 25 to 30 degrees Celsius for every kilometer. This effect is called the geothermal gradient, and it's what makes deep mines some of the most extreme working environments on the planet. And so you arrive. The first thing you notice is the heat. Not just warmth, but a stifling, humid heat that makes your clothes stick to your body and makes breathing difficult, like in a sauna. The temperature of the rock at this depth reaches 66 degrees Celsius, hotter than the water in a regular bath. Without cooling, working here would be impossible. A person loses consciousness at a body temperature of 42 degrees Celsius, and at 66 degrees Celsius at the face, heat stroke would occur in minutes. So every day, about 6,000 tons of ice slurry, a mixture of water, ice, and salt, is pumped down from the surface, cooling the air in the tunnels to approximately 28 degrees Celsius. 28 degrees Celsius is still hot, especially during heavy physical labor, but it's on the edge of tolerable. The Mponeng cooling system consumes enough electricity to power an entire small city. At the surface, giant refrigeration units freeze water into ice, mix it with salt to lower its melting point, and pump the resulting slurry through pipes 4 kilometers deep. There, the ice slurry flows into underground reservoirs, from where fans circulate cold air through the tunnels. Without this system, the mine would have to be closed. No one can work in temperatures below 66 degrees Celsius. Even with refrigeration, miners lose several liters of water per shift through sweat and must constantly drink to avoid dehydration. Heat stroke is common, and each working level has air-conditioned restrooms where miners can cool down if they feel unwell. The second thing you notice is the sounds, or rather, one sound. A quiet, incessant cracking coming from everywhere. It's the groaning of the rock. At a depth of 4 kilometers, the rock pressure is around 100 megapascals, the equivalent of a ton of weight pressing down on every square centimeter of the surface. The rock is under constant tension, and the slightest disturbance, or extraction, drilling, even the passage of people, can trigger a release of this tension. Miners call this a rock burst, a sudden outburst of rock when a piece of wall or ceiling is thrown into the workings with the force of a cannon shot. This is the main danger in deep mines and the leading cause of death. To protect them, tunnels are reinforced with steel arches, concrete segments, and diamond wire mesh, which holds the debris in place during an explosion. Every meter of excavation costs a huge amount of money, not so much because of the drilling, but because of the reinforcement. But it's impossible to completely eliminate the risk. In March 2020, a magnitude 2 earthquake struck Mponeng, killing 3 people. And in 2007, a shift in the mountain massif caused a magnitude 1.9 tremor. The tunnel walls literally jumped. At such depths, the earth doesn't just lie beneath you. It's alive, moving, and sometimes reminds you of it in the most terrifying ways. Miners say it's impossible to get used to. You learn to live with a constant feeling that the mountain could decide to close at any moment. Another danger that's rarely discussed is decompression. When a person ascends too quickly from great depths, the pressure drop can cause gas bubbles to form in the blood, the same phenomenon that affects deep-sea divers. In mines, this is less pronounced than underwater because the ventilation system partially compensates for the pressure drop, but the risk still exists. Ascending to the surface in the Mponeng elevator isn't just a trip home. It's a transition between 2 worlds, with different pressures, different temperatures, and different air compositions. The third thing that will strike you is the cramped conditions. The gold-bearing seam Mponeng mines is called the Ventersdorp Reef. It's a thin layer of quartzite and conglomerate containing gold inclusions. This layer is often less than a meter thick, sometimes only 30 centimeters. This means the miner works prone or on his knees in a space where it's impossible to straighten up. Imagine lying on your stomach in a stone box the width of a school ruler. The temperature is nearly 30 degrees. Water drips from the ceiling. All around you is the roar of drilling machines and the smell of explosives. The only illumination is a headlamp. If it goes out, you find yourself in absolute pitch darkness, the likes of which are found nowhere else on the surface of the earth. Even on the most moonless night, your eyes adjust and begin to discern something. Here, there is nothing. 0 photons. The darkness is so dense that it seems physically palpable. And so, in these conditions, you work for 8 hours, extracting rock that contains just 10 grams of gold per ton. 10 grams is less than the weight of a coin. To produce a single wedding ring, you need to process a ton of rock, dug up from a depth of 4 kilometers. When you put on a gold piece of jewelry, you're wearing the product of labor that's been wrought in a hell of heat, pressure, and darkness. Every day, approximately 6,000 tons of rock are removed from Mponeng. This involves using approximately 2.5 tons of explosives. Miners drill a series of holes in the gold-bearing seam, set the charges, and retreat to a safe distance. After the blast, the rock is crushed, loaded into mine cars, and transported along underground rails to the shaft, from where it is hauled to the surface. At the surface, the ore is crushed, milled, and chemically processed to extract the gold. Mponeng's annual gold production is approximately 8 tons. This may not sound like much, but at current prices, that's over $500 million a year. Is it worth it? It's a difficult question. On the one hand, there are colossal costs for electricity, cooling, safety, wages, and equipment. On the other, gold is always valuable, and the deeper the remaining reserves lie, the more expensive it becomes, because the easily accessible gold has long since run out. Mponeng is the last frontier of mining, a place people venture into only when there's nowhere else to go. 8 of the world's 10 deepest mines are located in South Africa, and they all extract gold from the same Witwatersrand. This speaks to 2 things: the incredible richness of these deposits and the fact that the upper layers have already been completely mined after a century and a half of continuous mining. Humanity is literally scraping gold from under its own feet, digging tens of meters deeper every year. But the most astonishing thing about Mponeng isn't found in the gold-bearing strata. It's found in the cracks of the rock, in the water that seeps through the stone at a depth of almost 3 kilometers. And it's alive. In 2006, Princeton University microbiologist Tulis Onstad and his team filtered 5,600 liters of water collected from deep cracks at level 104 of the Mponeng mine. They expected to find a diverse community of microorganisms, dozens of bacterial species, as is typical in groundwater. But the result was shocking. The water contained only 1 species of bacteria. One and only. A rod-shaped microorganism 4/1000 of a millimeter long, which they named Desulfurutus audaxviator, the intrepid sulfur traveler. The name was taken from Jules Verne's novel Journey to the Center of the Earth. Professor Liedenbrock discovers a secret Latin message: Descende audaxviator, descend, brave traveler, and you will reach the center of the earth. Scientists decided this name perfectly suited the creature that lives closer to the center of the earth than any other known animal. And here's what makes this bacterium truly unique. It doesn't depend on the sun at all. Every other living organism on Earth, from whales to viruses, depends on sunlight in some way. Plants use it for photosynthesis. Animals eat plants. Predators eat animals. Even bacteria in deep-sea hydrothermal vents use chemicals that ultimately depend on geological processes linked to solar energy. But Desulfurutus audaxviator has completely broken that chain. It gets its energy from the radioactive decay of uranium and thorium in the surrounding rock. The radiation splits water molecules, producing hydrogen, and the bacterium uses this hydrogen to reduce sulfates, generating energy from this process. It gets its carbon from carbon dioxide dissolved in the water, nitrogen from ammonia released by the rock. It produces all 20 amino acids that make up proteins. We humans can only produce 10. The rest must be obtained from food. It has tiny tails, flagellates, that allow it to swim in water. And if conditions become truly unbearable, even by its standards, it transforms into a spore, protecting its DNA from heat, desiccation, and acid. When conditions improve, the spore awakens and becomes a living bacterium once again. This creature is an absolute champion of survival, and it lives right under the feet of 4,000 miners, unaware of its existence. When biologist Dylan Chivian was choosing a name for the new species, he recalled Jules Verne's novel Journey to the Center of the Earth. In the book, Professor Liedenbrock discovered a secret Latin message: Descende audaxviator, et terrestre centrum attinges. Descend, intrepid traveler, and you will reach the center of the earth. Chivian said, "When we heard that name, we slapped our foreheads. That's it." Thus, the bacterium was named Desulfurutus audaxviator, intrepid traveler of sulfur, a name worthy of a creature that lives closer to the center of the earth than anything known to science. Water analysis showed that it hadn't mixed with surface water for several million years. This means that Desulfurutus audaxviator has been living in complete isolation from the rest of the world for millions of years, in pitch darkness, at 60 degrees Celsius, feeding on radiation. This is the first ecosystem ever discovered consisting of a single species. The only living creature in its own world, completely self-sufficient, needing no one else. Why is this important? Because Desulfurutus audaxviator is living proof that life can exist without the sun, and that changes everything we think about life on other planets. Mars, Jupiter's moon Europa, and Saturn's moon Enceladus all have subsurface oceans or aquifers where similar organisms could theoretically exist. If bacteria can survive on radiation and water in a South African mine, why can't the same bacteria live beneath the surface of Mars, where there's both uranium and water? Microbiologist Onstadt put it bluntly, "I think such an organism is ideal for the Martian underground." NASA is closely following Mponeng's research, not because they're interested in gold, but because 3 kilometers beneath Johannesburg may be the closest Earth analog to Martian life. If we ever find life on Mars, Europa, or Enceladus, it will likely look not like little green men, but like a tiny rod, 4/1000ths of a millimeter long, quietly munching on radiation in complete darkness. And the first hint of what such life might look like came not from space, but from a South African gold mine. Incidentally, Mponeng is also a place where events take place that would be impossible anywhere else on Earth. In 2017, an Ecuadorian marathon runner ran a half marathon, 21 kilometers, inside a mine. 21 kilometers through underground tunnels in 30-degree heat in complete darkness, illuminated only by a headlamp. Organizers declared it the deepest race in human history. It's hard to imagine a more surreal scene. A man running 4 kilometers underground, surrounded by gold-bearing rock compressed by pressure, in a world where the only other living things are uranium-feeding bacteria. Incidentally, in 2021, an international team of scientists made another discovery. Nearly genetically identical populations of Desulforudis audaxviator were found in the deep groundwater of South Africa, Siberia, California, and Sweden. Separated by thousands of kilometers and different continents, these bacteria turned out to be genetic twins. More than 99% of their DNA is identical. How is this possible? Scientists hypothesize that all these populations descended from a common ancestor that lived millions of years ago, before the continents drifted apart. Since then, each population has lived in complete isolation, but has changed so slowly that even after millions of years, they are almost indistinguishable. This is one of the slowest rates of evolution ever recorded in living organisms. Life at the bottom of Mponeng doesn't just exist, it's frozen in time, like an insect in amber. Only amber is 4 kilometers of rock. Mponeng has another, less scientific but no less dramatic side. The mine is not only a workplace for the 4,000 official miners, it is also a habitat for so-called ghost miners, illegal prospectors who enter abandoned or unused workings and extract gold at their own risk. Some live underground for months without rising to the surface, surviving on food passed through ventilation shafts by their accomplices. They work without protective equipment, ventilation, or medical care. These are desperate people for whom a few grams of gold is the difference between poverty and survival. Mine security constantly fights them, but the labyrinth of 400 kilometers of tunnels is impossible to completely control. By some estimates, illegal gold mining in South African mines earns criminal networks hundreds of millions of dollars a year. Makeshift camps have been repeatedly discovered in Mponeng, complete with mattresses, food supplies, makeshift kitchens, and even electric generators connected to mine cables. This is the dark side of the gold rush, which continues into the 21st century. Only instead of picks and pans, prospectors now have hammers and sacks, and instead of the Wild West, a 4-kilometer-long underground tunnel. Mponeng is a place where extremes meet. Cutting-edge cooling technology and medieval working conditions in 30-centimeter-thick crevices, world-class astrobiology, and illegal gold mining with bare hands, bacteria that survive for millions of years without a single ray of light, and people risking their lives for a few grams of yellow metal. The deepest man-made object on Earth, and one of the most dangerous workplaces in the world. 4 kilometers of rock between you and the sun, and in that rock, in every crack, in every drop of water, is life. Life that needs neither light, nor oxygen, nor us. Life that was here long before the first miner struck rock with a pickaxe, and will remain here long after the mine is closed and flooded. Do you know what strikes me most about the Mponeng story? Not the depth, not the temperature, not the gold, but the sheer scale of the contrast. On the surface, it's the 21st century, smartphones, satellites, artificial intelligence. And 4 kilometers beneath your feet, a man lies on his stomach in a rock crevice, chiseling away at the rock, just as his ancestors did thousands of years ago. Technology has lifted us into space, but at the bottom of the world's deepest mine, work still comes down to muscle, sweat, and stone. And next to this man, in a crack in the rock, lives a bacterium that feeds on radiation and hasn't seen the sun for millions of years. A bacterium that could prove to be a model for life on Mars. 4 kilometers down, and you find yourself simultaneously simultaneously in the past and the future, in the Stone Age and the Space Age, in the most dangerous and most amazing place on Earth. Tell us in the comments what struck you most, the miner's working conditions, the radiation-eating bacteria, or the sheer scale of the mine itself. And don't forget to subscribe, because there are still many more journeys ahead to places where normal people prefer not to go. See you there.